In the previous video, we saw how to name organic molecules, or alkanes with substituents more specifically. But we could actually go in the other direction as well. We could go from the name to the molecule. I find this version to be a bit more straightforward because it really depends, the numbering and everything really depends on how you draw it. So what you'll do is you'll look at the name, you'll draw the parent name first. So draw the parent chain. I should say we draw the parent chain first. Then you'll number the parent chain and then attach the substituents accordingly. So this version tends to be maybe not as tricky. So to find the parent name, I'm always going to look at the very end of the molecule name. This is saying octane. Ane is telling me that it's an alkane, which means that these are all single bonds. And oct is telling me that there are 8 carbons in that molecule. So I'm going to start by drawing an alkane with 8 carbons. All right. And then I'm going to number the parent chain. And here it doesn't matter which direction you go in because you don't have any substituents on there yet. You are going to decide where you're going to put those substituents. So I numbered left to right. Why not? You could have gone in the other direction as well. And then I'm going to attach the substituents. And I see on carbon 4, there will be an ethyl group. And eth is telling me that there are 2 carbons on this particular substituent. So I'm going to locate carbon 4, it's right here. And I'm going to attach 1 carbon and 1 more. And there's my ethyl group. It contains 2 carbons. And then I see that on carbon 2, there are 2 methyl groups, right? So di is telling me that there are 2 methyl groups attached to carbon 2. So I'm going to locate carbon 2, which is right here, and I'm going to attach 1 and 2 methyl groups. And that's my 4-ethyl-2,2-dimethyl octane. Note that I'm drawing all of these in the line angle format. You could turn this into an expanded version or a condensed version. So just make sure to pay attention to what particular format the problem is asking you to do. Here I didn't specify, I prefer the line angle format, so I always just kind of intuitively draw that one. Let's try another one. This says 1-bromo 2-methylpentane, so I'm immediately going to go to the end of that name. Ane is telling me an alkane, so these will all be single bonds. Pent is telling me that there are 5 carbons in the parent chain. So I'll go ahead and draw pentane. Then I'll number all the carbons. And then I'll attach my substituents. It looks like on carbon 2, we have a methyl group. So on carbon 2, I'm going to attach a 1 carbon substituent, which is a methyl group right here. And then on carbon 1, there is a bromo. So on carbon 1, I will attach a bromine. Note that you didn't have to draw it in that particular direction, so I could have also had bromine going in this direction, and that would have been just fine as well. These single bonds rotate, so you don't have to stress too much about which way you had pointing. And let's do one more. This one is 3-ethyl-4,7-dimethyl-nonane. So I see that ending ane, so definitely an alkane. It will all have single bonds. Non is telling me that there are 9 carbons in this chain. So I'm going to start by drawing a 9-carbon alkane. Ooh, that one's long. I hope I didn't miscount there. Let's see. No, we're good. Okay, 9-carbon alkane. Then I'll go through and figure out where to attach my substituents. We have a 3-ethyl. So on carbon 3, I'm going to add a substituent that has 2 carbons. So there's my ethyl group. And then on carbons 4 and 7, we have methyl groups. So dimethyl is telling me that we have 2 methyl groups on this molecule. So there's 1 on carbon 4 and 1 on carbon 7. And that's my 3-ethyl-4,7-dimethyl-nonane. So I think this direction is not quite as bad.